Okay, so we're looking at least to most reactive dienes here. Okay, so let's take a look at and observe what we have. Remember that the electron donating groups are going to raise the energy of the conjugated diene pi, or HOMO, highest occupied molecular orbital energy state. So, in other words, we're going to need electron donating groups. So the two electron donating groups that you see right here are this propyl group as well as this ethoxy group. Okay, so the ethoxy group is going to be slightly more electron donating. Remember, well, actually way more electron donating because it actually has a lone pair to feed in. This just has some inductive effect. Okay. And then you have some inductive effect here with that carbon directly attached to the diene. However, you have an oxygen that's pulling electron density away. Remember, oxygen's most electronegative, at least in this context. So, in other words, this is going to be the slowest, right? Because we're looking for electron donating, not electron withdrawing. So, in other words, you're going to see I guess I had it way wrong. TUV, I was writing it wrong. So it was actually S. My apologies for that. So this is going to be fastest, this is going to be medium, and this is going to be slowest. So least reactive, intermediate, most reactive. Okay. So slightly electron donating, mostly electron donating, slightly electron withdrawing here. So it's going to go T, U, S. Okay. Greatest, weakest. Okay, now 24.39. Remember that the dienophiles are going to be, they're going to need electron withdrawing groups in order to lower that LUMO energy level. So, okay, let's take a look at, so we need some electron withdrawing groups. So in other words, the only thing that we see that is electron withdrawing here about the dienophile is going to be these cyano groups that you see here in O and P. So the more electron withdrawing groups you have, the faster that reaction is going to take place. So in other words, O is going to be the highest, okay, followed by P, okay, and then we have N, which stands for neither nor, I guess. This is just going to be ethene. So that is going to be right there, sort of as a benchmark, sort of zero sum, not very reactive but not unreactive, so somewhere in the middle. Okay, and then when you have some electron donating groups, that's going to actually raise it a little bit higher. So it's, again, what we saw with our dienes, right? So in other words, electron donating groups like this are going to actually slow down the dienophile reactivity. So in other words, Q should be the second least, and then R is going to be the least. Okay, so it should go R, Q, N, P, and then O.